The world's dependence on oil and gas is a given. Without these fuels, life as we know it would grind to a stop. Many people believe that once oil or gas is found, simply punching a hole in the ground will allow it to flow. In reality, drilling a well is a complex process involving 10 to 30 different service companies, each one adhering to stringent around-the-clock scheduling, safety, and environmental practices. Understanding how a well is drilled goes a long way toward understanding why producing oil and gas takes so much time and money. The first task is to prepare the location. This starts with building a road for access to the site, clearing the area where the rig will sit, and providing infrastructure for water and electricity. To prevent contamination of the soil or water table during drilling, an earthen pit is dug and lined with a thick layer of plastic to hold rock cuttings and drilling mud. Next, a pilot hole is dug at the precise location marked by the survey crew for the main hole. Two other holes, the mouse hole and the rat hole, are also dug in close proximity to the main hole to hold pieces of equipment and pipe during the drilling process. It's then time to bring in the rig equipment to rig up. A rig that can drill a 10,000-foot well requires 50 to 75 people and 35 to 45 semi-trucks to move and assemble the rig, normally in about 3.5 days. The rig is then inspected to make sure it meets all specifications and safety standards. Rig operations continue 24/7, typically ceasing only 1 day per year on Christmas. 2 shifts of complete crews are assigned to the drill site for the entire project. Drilling happens in stages: drilling, running and cementing new casing, then drilling again, until the bit reaches the depth of the targeted zone. A bit generally lasts for 4,500 to 6,500 feet of drilling. Replacing the bit requires removal of the entire string of drill pipe. Called tripping out, it is a process that can take several hours. Before this is done, derrick hands mud up or circulate drilling fluid through the hole to cool the bit and keep the walls of the hole intact. To help keep cuttings from plugging the hole, this mud passes through shakers that separate the cuttings and send them to the pit. Additional mud system equipment, desanders, desilters, and degassers remove smaller particles and gas from the mud. The clean mud is then recirculated back down into the hole. The blowout preventer, or BOP, is installed on top of the casing head before drilling commences. It contains high-pressure safety valves designed to seal the well hole and block the escape of underground gases or fluids in order to prevent a blowout from occurring. Drilling begins with a hole of a designated surface depth, usually about 50 to 100 feet below the water table. Special care is taken to prevent contamination of the groundwater by isolating the water table from the well with cement and steel casing. The bit is the cutting element used in rotary drilling. As the bit turns, it crushes the rock efficiently, then shoots fluid out to loosen and carry these rock chips up to the surface. New sections of pipe are added to the drilling string as the bit drills deeper. When the hole reaches a designated depth, the derrick hands circulate fluid through the hole to condition it for logging, the process of measuring and recording the characteristics of the well. The logging information lets the oil company determine if the well indeed can produce oil or gas. At this point, the company will decide whether the well is to be completed or plugged and abandoned. If the well is designated as a producer, the crew inserts the pipe back into the hole to ensure that the hole is still intact and circulates mud through it again to test the casing. If everything tests positively, they remove the drill pipe and rack it. At this point, the crew inserts the last string of production casing that runs the entire length of the hole and cements the casing in the hole. The production crew then brings in the workover unit and rigs it up to prepare the hole for production. The crew runs small diameter tubing into the hole as a conduit for oil or gas to flow up the well. Next, the workover unit trips out of the hole and picks up a perforating gun, which the crew lowers into the well to production depth using a thin metal cable called a wire line. An electrical signal is sent down the wire line, firing the gun and igniting explosive charges. These charges create holes through the cement, casing, and formation, connecting the well bore to the reservoir. To stimulate the flow of hydrocarbons, sometimes it is necessary to frack the well. This involves pumping air, sand, and fluids under extreme pressure down the production tubing and out through the perforations. The process fractures or forces cracks into the formation. The remaining particles will hold the cracks open, releasing the oil or gas. Monitoring the flow enables the crew to determine the best location for the choke, the device that controls the flow of the oil or gas. Hydrocarbons were created from organically rich deposits subjected to tremendous heat and pressure. This same pressure has kept the hydrocarbons locked in the formation for millions of years. Once the pressure is released, the hydrocarbons are allowed to escape through the fractured zone and flow into the wellbore. The oil and gas can now travel up the casing string. The wellbore is isolated from the surrounding formations with casing and cement, preventing any contamination. The final step is to install a pump jack or production wellhead called a Christmas tree on the well. It is then time to produce the well and plan for any future field development. Many other factors can affect the oil and gas drilling process, but the bottom line is this: to meet our growing energy needs, we must increase supply. And drilling for oil and gas will help meet this need.